Okay, so you just finished figuring out this first one here, and I'm hoping that for an answer, what you got was 9.16. This first figure here, this hypotenuse, should be 9.16. And that for the second one here, you got 9.32. 9.32. Okay, so you found the hypotenuse of this right triangle here. I forgot to put the right sign there, I'm sorry. And you found the leg of this right triangle as well, and this one is 9.16, and the second one came out to be 9.32. So now we know a little bit, we have a little bit better understanding of how to do the Pythagorean theorem. Now why is this important? Well, because they're going to be higher order questions that we're going to have to incorporate the Pythagorean theorem into. Let me show you what I mean by that. Let's say, for example, that they give me a triangle here, and they tell me that it's equal angular, all the angles are congruent, and they give me one side that's 6. Well, a couple things. I know that if a triangle is equal angular, then it is also equilateral, meaning that because if all the angles are the same, then that means that all of the sides are also going to be the same. So if this side here is 6, then I know that all of the other sides are also going to be 6. Okay? Well, let's say they ask us to find the area of this triangle, right? Well, in order to find the area of a triangle, we have to use the formula. Area is equal to 1/2 base times height, okay? And again, that formula is on your reference sheet in case you don't remember it. And also remember that the area of a square is the base times the height. And remember that a triangle is half of a square. So it's half the base times the height. Well, here, obviously, my base is going to be what? It's going to be 6. But what I'm missing is the height. What I'm missing is the height. So what I'm going to do is I'm going to take my triangle and I'm going to split it in half. Now, by splitting it in half, both of my sides are going to be what? They're going to be 3 and 3. Okay? Now, why is that important? That's important because if I take my triangle and I cut it in half, let me show you here. And you look here, well, if I cut it in half, what did I just create? I just created a right triangle. And what can I use to find the height of this triangle? I can use the Pythagorean theorem. Sure, my hypotenuse is 6. Let me move this a little bit further this way. All right, can everybody see that there? My hypotenuse is 6. And now this base of the triangle, this leg of the triangle is what? Is 3. So I can find the height using the what? Using the Pythagorean theorem. Again, this side could be A and this could be B, or this could be A and this could be B. It doesn't matter as long as this is what? As long as this is C. So here's my Pythagorean theorem. A squared plus B squared is C squared. 3 squared plus the other side squared, which I don't know, is equal to the hypotenuse, 6 squared. So that's 9 plus B squared is 36. Subtract 9 from both sides. B squared comes out to be 27. I take the square root of both sides, and B is equal to 5.19. So then that means that the height of this triangle right here, this height right here, is 5.19. Well, now that I know that the height of this triangle is 5.19, I can find the area of the triangle, because the area of a triangle is half the base times the height. Well, here's my formula. Let me plug it in. A is equal to 1/2 the base of the entire triangle. What is 6? Don't confuse it with the 3. We did that to find the Pythagorean theorem, but we're looking for the area of the whole triangle. So it's half the base, which is 6, times the height that we found, which is 5.19. When I plug those all in, I get 15.57. So the area of this triangle here is 15.57 inches squared, or centimeters squared, whatever the units are. Okay, and that's why it's important to know how to do the Pythagorean theorem, so that, because sometimes we're going to be forced to get creative and cut triangles in half, find their heights so we can find their areas. Okay. Now, one of the other things we discussed earlier was adding like terms of square roots, right? Let me show you another instance where that's important to know. Here I have a pentagon, and the area of this triangle in the pentagon, let's assume it's an equilateral triangle, is 12 times the square root of 3. And they might ask you a question, for example, that says, what is the area of the entire pentagon? What is the area of the entire pentagon? Well, I would hope that you notice that the pentagon, I could put more triangles into the pentagon, right? I don't know if you can see, excuse me, sorry about that. I don't know if you see that, but I hope you can notice that you can put the triangle actually in more places in the pentagon, right? There'd be another one there, right? So that's another triangle there. There's 2. There'd be another one here. That's 3. There'd be another one there. You could 4, right? Of course, my picture is not perfect, and there's another one here that you can put around. That'd be what? That'd be 5, right? So there'd be 5 more of these. So the thing is, if there are 5 of them, and only one of them has an area of 12 times the square root of 3, what would be the area of the entire pentagon? Well, it'd be 12 times the square root of 3 times 5, right? For the 1, 2, 3, 4, and 5 triangles that we would have here. So in essence, it'd be 12 times the square root of 3 times 5, which is 60 times the square root of 3. It's like saying 12 of these 3's, right? Well, you'd have times 5 is 60 of those square root of 3's. So the answer for the area of this pentagon would be 60 times the square root of 3 inches squared. And that's why it's important to remember how to add square roots. So it's important to know how to multiply square roots in case we're dealing with the Pythagorean Theorem. And it's important to know how to add square roots in case we're dealing with areas. Okay? So right now, let's work on our worksheet, which is, I believe, page 86. And let's work on numbers 6 through 11.